Hi everyone, welcome back to Maths Hub's YouTube channel. This is our ongoing series to help you conquer the GMAT Focus Edition exam. In today's video, we'll be covering some solved questions on the topic of fractions, which also includes some other interesting topics which will be really useful on your journey to conquer the GMAT. Let's get started. Great, so here is our first question. So this question has two different fractions, and you notice that there is a fraction in the denominator of both the fractions as well. So when you have something like that, you don't have to panic. You just need to take the denominator part separately and just solve that, and then you'll eventually land up with something which you can work with more easily. So let's just solve the denominator parts first. So first, this is 2 plus 1 by 3. So if you take the least common multiple, right? So you're gonna multiply this by 3, right? So you're gonna multiply this by 3 because the common multiple is for 1 and 3 is 3, right? 1 times 3 is 3. So the common multiple of 3 for both 1 and 3 is 3, right? The least common multiple. So you're gonna multiply this also by 3 since you need to keep the fraction constant, and you're gonna do the same for this part, right? So this is the denominator 1 when you don't have a denominator for any number, multiply it by 3, multiply the numerator also by 3, the same process exactly. So you're going to have 2 times 3 by 1 times 3 minus 1 by 3, right? And what do we have next? The next part is we go 1 by, so 2 times 3 is 6 by 3 plus 1 by 3. And over here we have 1 by 2 times 3 is 6 by 3 minus 1 by 3, right? So next step would be, so since the denominators are the same, we don't have to change the LCM. We can just go with the same denominator and then we can add up the numerators, right? So that will be 6 plus 1 by 3 plus 1 by 6 minus 1 by 3, which is 5. Or let me take it step by step to make it simpler for you. So that's going to be 6 minus 1 over 3, correct? So if you simplify that further, you get 1 out of 7 by 3 plus 1 over 5 by 3, right? Next, what do you have? So this is going to give you 3 over 7, correct? So when you have a fraction which is in the denominator, and when you flip that over, you can flip it over. So the way you would do that, the way to understand that would be, so when you have a fraction in the denominator, to convert that into a more proper looking fraction, what you can do is consider this entire thing as also a fraction, right? This is also a fraction apart from the fact that the denominator itself is a fraction. If you assume that this is some a, right? So let's say it's some a equals 7 by 3. You can also assume that this is also a fraction, right? So here let's multiply a with 3 and multiply 1 with 3. So if you multiply this with 3 and you multiply this with 3, you understand that you can convert this to a proper fraction, right? So you can say 3 times 1 is 3, and here you can cancel out 3 and say 3 by 7. So this is exactly what you get when you just flip it. Instead, you could just flip the whole fraction and take 3 to the numerator directly when you have a fraction in the denominator, right? So the same thing you can do it here. Take the 3 directly to the numerator, and that will be 3 over 5. And now we have to solve these addition of these fractions as well. So we need to take the LCM of 7 and 5, right? So what's LCM of 7 and 5? Since both are prime factors, you just need to multiply the two, which will be 7 times 5, which is 35. So multiply this by 5. So you're going to multiply the numerator by 5 as well. So multiply this by 7. So you'll multiply the numerator by 7 as well. So that's 15. 5 3 is 15, and 7 3 is 21. So the entire thing with 15 plus 21 is 36. So it's 36 by 35. That's the final answer, right? So that will be that's option E. Option E is your correct answer. Great. Let's move to the next question. So this question looks a little bit, it's a combination of cube roots, squares, and fractions. So let's tackle that. So the numerator is cube root of 0.00006 and 4. And the denominator is 0.02 square. So to solve any such question where you have a cube root or a square root, you must try to break up the number inside into factors. So since you have a cube root, it's most likely that the question would have you break it up into usually 3 factors, which will help you take the cube root out, right? Which will help you take the numbers out of the cube root so that you can solve the entire question. So we have to figure out a way to convert this into 3 same factors. For example, if you have a cube root of 8, right? So if let's say it's a cube root of 8, so you have to realize that 8 it's 2 times 2 times 2. So we have the same factor appearing 3 times, and that's when you can take these out of the cube root and say it's 2. So cube root is nothing but it's a reverse operation of the cube, right? So when you have 2 cube, 2 to the power of 3 is 8, you can say 2 is equal to the cube root of 8. So that's the idea of a cube root. It's a reverse operation from an exponent. So to solve any cube root or any under the root question, you will have to convert the number inside into that many number of factors, which are same factors. So if it's a square root, which you don't really write a 2 in the case of the square root, but you would have to convert this into 2 factors, a into a, so you can write it as a. So if it's a cube root, you have to convert it into 3 factors, b times b times b, and so you can say that's b. So that's how you'll solve these questions. So to do that, let's figure out what this can be. So 64, what is 64? Does that give you any clue? So the clue is that 64 is basically 4 times 4 times 4. You need to understand this, or you need to probably recall this. This comes with practice, right? So if you recall that 64 is 4 times 4 times 4, you know that this has something to do with number 4. So what happens if you have 0.4 times 0.4 times 0.4? What does this multiplication give you? So if you multiply 0.4 times 0.4 times 0.4, in our decimal series we discussed that in our GMAT course that we are building, we have discussed about decimals. We'll also be creating a YouTube video on that. So basically the way you multiply decimals is you ignore the decimal first and multiply the numbers. So you have 4 times 4 times 4 is 64, right? And then you add back the decimals, just 3 decimals over to this number. So that will be, you need to add it 3 times, you need to put it to the left 3 times, right? So you start here 1, 2 and 3. So this is what the multiplication gives you for these 3 numbers. But this is still not exactly what our number is, correct? So that means we can't really say that this is exactly the same number. But we have another option here. So what we could do is, you can multiply this with a 0.1 and a 0.1 and another 0.1. So if you have 3 0.1s, you could have 3 more decimal places to the left, correct? So now we have the decimal place over here. So if we need to have it 3 more times, right? 1, 2 and 3, we need to have further 0.1, 0.1 and 0.1. So we could have the cube root of 0.4 times 0.4 times 0.4 times 0.1 times 0.1 times 0.1 and divide that by 0.02 square. So the reason, see, the whole idea of solving this is all about figuring out how you can write this, how you can express this as 3 different, express this as 3 times writing the same number. If you are able to write this as a product of the same number written 3 times, you will be able to get it out of the cube root. Right? That's the whole point of this question, you being able to figure that out. So the cube root, so when you have an exponent over multiple numbers, you know that you can distribute out into multiple numbers, right? So when you have a cube root of 0.4 times 0.4 times 0.4 and 0.1 times 0.1 times 0.1, you know that cube root of this is nothing but 0.4. Because 0.4 cube, 0.4 times 0.4 times 0.4, correct? It's basically, cube is basically multiplying the same number 3 times. So a cube root, so if you push the 3 over this way, right? You push the 3 over that way, you will end up with exactly the same thing. You will end up with 0.4 equals cube root of 0.4 times 0.4 times 0.4, and that's exactly what we have done there, correct? So this means this cube root of 0.4 times 0.4 times 0.4, and this is the cube root of 0.1 times 0.1 times 0.1. So there will be, this entire thing becomes one number, this entire thing becomes another number, correct? So that will become 0.1 here. And then you have 0.02 square here. Okay, so what can we do here? So let's try to tackle that. So 0.4 times 0.1 will give you 0.04. Or I usually like to write it as an exponent, or let's tackle the denominator first. So this is going to be 0.02 times 0.02. So if you see, this 0.02 and 0.04 are they have the same number of exponents, right? So they have the same number of decimal points. I usually don't like working with decimal points because I feel it's a little more confusing for my understanding of visualizing things. So I like to write it as an exponent. So instead of 0.04, I'm going to write it as 4 times 10 power minus 2. And instead of 0.02, I'm going to write it as 2 times 10 power minus 2. And this also as 2 times 10 power minus 2. Right? Now I know that 2 times 2 is 4, I can cancel this out. 2 times 1 is 2, I can cancel that out. So I'm only left with something very easy to work with, which is 10 power minus 2 by 10 power minus 2 times 10 power minus 2. I'm just going to cancel one of them out, that's also away. So I'm only left with 1 by 10 over minus 2, which is 1 by 100, which is 0.01. That's it. And that is your answer. So the answer to this question would be, answer to the entire question would be 0.01. Or you could also say 1 over 100, whichever the option gives you. Let's go to the next question. Great, so let's look at this question. This seems pretty straightforward to me. This is simply an addition of multiple fractions. You could also say it's an addition of a harmonic progression, right? So it's 30 times 2 is 60, 60 times 2 is 120, 120 times 2 is 240. Or you could go by the traditional LCM method of solving this. So let's say we have this, right? It's actually a pretty fairly simple question. All we need to do is just take the LCM, right? So the whole trick in solving most fraction questions is finding the LCM, right? So what is the least common multiple, right? LCM is least common multiple. I hope you all know that. Least common multiple, right? So being able to take LCM is all about understanding which of these numbers or any other number would be a number which will be a multiple of all these numbers, or all of these numbers will be a factor of that number that we choose, the LCM number. And that has to be the least number. It could be, of course, you could have infinite multiples, right? There's no end to that, but you need the least one, which will ensure that all of these numbers are a factor of that number. So that means, in this case, it's actually pretty straightforward. You know that 60 is a multiple of 30, 120 is a multiple of 60, 240 is a multiple of 120, which means 240 is the LCM because 240 is a multiple of itself, 120 is a factor of 240, 60 is a factor of 240, 30 is a factor of 240 because 30 is a factor of 60, and 60 is a factor of 120. So 240 is the LCM, and that's very, very straightforward. So if you take the LCM as 240, you're going to multiply this by 8, right? So 8 3s is 24, so 38 is 240. So you multiply this by 8, and you multiply this by 4. 60 times 6 times 4 is 24, so 60 times 4 is 240, and 12 times 2 is 24, so 120 times 2 is 240, and 240 times 1 is 240. So this is just multiplied by 1. If you write them over here, so this is 8, so 8 times 1 is 8, so 8, this comes over here, 8, this comes over here, 4, this goes over here, 2, and this goes over here, right, 1. So it's 8 plus 4, 12 plus 2, 14 plus 1, 15 over 240. That's right. So that's 5 times 3 is 15. So 5 times 4 is 20, 5 8 is 40, 3 over 48. Or 1 over 16. 3 times 16 is 48, so 1 over 16 is the answer. So answer is option B. Let's go to the next question. Awesome. So this looks very simple, but yeah, let's tackle it. So it's 1 minus 0.2 by 1 plus 0.2. Just nothing but 0.8 by 1.2, which is 8 over 12. So that is 4 2 is 8 and 4 3 is 12. So 2 over 3. That's very, very simple. Sometimes we end up with some simple questions as well. Awesome. And that's the end of the video. If you like the video, please hit the like button to support our channel and share it with your friends. And do subscribe to our channel for more such interesting videos on this ongoing series to help you conquer the world of GMAT. Thanks and have a nice day.